How you doing, everyone? This is Harold, um, Dr. Miller's stats class. This has been a long journey. So, 8.0, I guess let's start off with when comparing um, models that have hierarchical multiple regression. How do you determine which is the best model? I would venture to say, from a theoretical perspective, before there's any type of regression analysis, I think you have to develop an idea as to, which are going to be your most important variables, along with their relationships, the coefficients, size and effect, magnitudes. I think that is important. So, with that being said, I think with theoretical considerations, you should not discard them based on based on statistical measures. I think, for example, if you include a predictor in a model, even if, let's say, the p-value is not significant, I think bringing in complexity, I think using simpler models in and of themselves provide, I think, a more precise prediction as opposed to more complex models. I think another means in which to determine better models would be using the residual plot effect. I think that's a good way to avoid inadequate models altogether. Okay, so how do you interpret unstandardized um, regression coefficients in a predictor variable? I think understanding the symbol of unstandardized beta. Um, so, with that, there's variable one, and I think variable one, in essence, um, has much to do with um, um, well, unstandardized beta is, oh my goodness, how would you say? Um, um, Portrays, expresses the slope of the line between the predictive variable and dependent variables. Yeah. So where there's variable one is, in essence, is describing for every one unit of increase. There's also unit of increase in variable one. There's also an increase in the dependent variables as well. That's to also be considered. Okay, let's say if the regression coefficient in a particular variable is 0.52, 0.57, and the other is a negative 47. What does that mean? And again, I have to go back with trying to understand symbols or how to read the regression table, which can be confusing. Looking at that, there are five symbols. Reading the table from left to right, you have what's called unstandardized beta. You have standard error for the unstandardized beta. You have standardized beta. Then there's the t-test static. And finally, there is your probability of p-value. Now, looking at the regression table, you have to know by plugging in those numbers just pretty much whether your values positive or negative, and whether your indicators are going to be significant or not. I'm probably babbling here, but that's kind of the gist of how I kind of see that in and of itself. Moving right along, with which regression coefficient, unstandardized and standardized, would you compare to determine which is the most important predictive variable in a model? And I think, generally speaking, the variables with the highest correlation is a good predictor. You can also compare coefficients, and which will allow you to select the best predictor. So yeah, there's that piece. And I think that in and of itself, there's something else to that. Oh, I just went blank. Maybe I'll try to come back to that. Okay, so in comparing regression coefficients, would you compare a regression coefficient of all the predictor variables, or just the regression coefficients of significant predictor variables? I think I got that question right. Anyway, statistically speaking, you can do this through the statistical output, which displays a coded coefficient, and which ultimately is your standardized coefficient, and your standardized coefficient is let's see, hold on. So your standardized coefficient is your oh man. Oh, hold on. Yes, your standardized coefficient represents your largest absolute value of what is considered to be the most important variable within the regression model. Oh, anyway, so yeah, I know I'm missing some other things with regard to this, but and as far as the other point, in terms of the regression coefficient of unstandardized and standardized, I think another thing is to take into effect the absolute value along with R², and how those two can be, if changed, can also affect the outcome there. Anyway, oh mercy. Yeah, so thank you so much, and I will see you soon. Bye.